In this video, I am going to talk to you about networks and system security. A portion of it is local area networks and wide area networks, LAN and WAN. First of all, today people are linked by wires, especially in the past, or wireless, carrying voice and computer signals via the telephone system. Data communications dominate the world today. Even in our personal life and business life, that computers and data communicated computers really are an integral part of it. So the computer network is the linkage of computer systems, not standalone, by means of communication lines and channels, such as fiber optic, microwave, satellite, telephone line 802.11, and which we are going to talk in this chapter. First, let's start with local area networks. A LAN is a linkage of computers in a specific geographical area, usually within an office or building, such as in hotels, restaurants, country clubs, using transmission mediums such as twisted pair wire or coaxial cable. Today, you can also do WLAN, wireless local area network, by using Wi-Fi, and we are going to talk about this. Look at this example that you see here. This is a sample of a local area network by using three different topologies, and we're going to talk about topologies, but topology basically is refers to linkage of these computers physically or logically. Here we have the star, and we have the bus, and this is the ring topology. And like I said, we're going to talk about them in more detail. So let's see a typical local area network in a hotel, right? You go into a hotel as a guest, you make a reservation, you check in, you get your room key, and then you go into your room, and then you go out and eat something in the restaurant, maybe go to the fitness center, go to the gift shop, and all of these things are happening. And all of these functions are supported by computer systems behind the scenes. And you can see here that this is a star topology which is used. This is my server here in the center, and this is my front desk terminals, and which is attached to electronic locking system, energy management system for my room, accounting system, that's my PBX switch that controls my telephone lines. CRS is central reservation system that connects me to the outside world when it comes to the reservations, and GDS is global distribution system. Point of sale is all the point of sale systems such as restaurant, gift shop, and call account system is the system that manages my telephone inside the hotel. So when I connect all these different systems by using a server, which also hosts the PMS, which is the heart of the hotel, that's property management system, now you created a local area network. This is a very typical and a very good example of LAN in a hotel environment. Look at this. This graph looks a little bit more complicated, but do not worry, because what you see here on the top level is exactly like this. Look, it is very similar, right? So you have your PMS computers. This is your point of sale computers, which also attach to kitchen printer. Here we put painter, but it should be printer. Kitchen printer and or kitchen display systems here. And of course, that's my back office systems here. So that's a hotel unit level. And then if I can, this is a local area network. And then I can attach this to my enterprise level, which we are going to talk a little bit later. That's my main server, and also through the modems I can connect to other things like CRS. We talked about this earlier. So you actually basically what you are doing right now, or what you are looking at right now, is the wide area network for a hotel. So what do you need to create a LAN, local area network? You need several different things. You need a server, right? You need a workstations like you see here. That's my workstations, and that's my server in the middle. And you need network operating system for your server. you need network interface card or adapter, just like you see in this picture, for your computers to be attached to the server, right? You need a switch or hub. Hub, it was in the past, they were not smart, but switch, like you see in this particular example here, is the device that allows the data to be communicated in your local area network. For example, if this computer would like to send any kind of a message data to this computer, it first sends to switch, and switch understands where it's sent to, and then it sends that to the appropriate server. Imagine this switch like a post office. When you send a mail, it goes to the post office. Post office looks at the address. Oh, it is for this one. Then it goes and delivers to there. In a hub, it's the same idea. Just to show you the difference, is that when this computer here sends the signal to this computer in a hub, when this hub sends this signal to all computers in the hub, in the network, and then these computer will say this message is not intended for me, it will reject, and this computer will do the same and do the same, and this computer will say, hey, this message is for me, I'm going to accept it. And of course, in a local area network, please notice that I'm not saying wireless local area network, that if it is at LAN, you need cables. Cables can be Cat5, Cat6, fiber, and we're going to talk about that in a second. Servers, right? Here's two examples of a server. This is from HP, they're from IBM. Their cost usually about anywhere starts from 5,000 and upwards. You can see that this particular server has multiple slots here. So this is a scalable server, right? Right now there's 1, 2, 3, 4. These could be hard drives, this could be memory, this could be anything that a computer can take on. So servers basically computers, but they are powerful computers. So these ones have some empty slots here that allows us, as the volume of data and processing increases, that we can actually make this server a better server. Or a server could be just in the form of a desktop. You know, this could be a powerful desktop, could even be a server or function as a server for a small hotel or restaurant. But I just wanted to tell you, or it may actually look like this. It is complicated. Like, for example, look at these, all the switches and the servers. You have multiple things. This belongs to a big hotel. Why? Because you have many different functions of servers. And if you're a small hotel, you can actually do all of these functions that you see on the screen in one shot with one server. Or you can actually have different servers, such as file server, holds and distributes the files. Print server handles the printing jobs from clients. Let's say, imagine that there's a big hotel and you have 3 big printers. Everybody send their printing jobs to these particular network printers, and you may need a server for this. It does not have to be a separate server, but in a big company, in a big organization, it should be a different server. Proxy server performs a function on behalf of other computers. Application server, that's your network application, for example, that hosts the Marsha, Marriott Central Reservation System. It is still used to this date. Web server, if you are running your web pages through your server, let's say you're an independent hotel, then you may need a server for that one. Mail server for emails, fax server, voice over IP for your telephone that's over the internet lines is voice over IP. So these are, and we also said that you need cables. What are these cables? Could be, there are different cables out there in the market. The most common one is twisted pair. This is your telephone cable, or if you ever connect to the internet through the Ethernet cable, this could be a good example. Or if you have TV at home and you're using cable, the cable, then you're using a coaxial cable. Or some of you may even have fiber all the way inside your home for your internet. Then this is another form of a cable. So just to show you, this is called RJ45. RJ45 basically is your Ethernet cable, right? And this is RJ11. it's a very nice and fancy way of saying telephone cable. This is your regular telephone cable. You can actually create a network by using RJ11 cables. Although today most of the networks are created either RJ25, and here's the example. So this is your telephone cable here. That's a little bit smaller slot, and the jack for the RJ45, it's a little bit wider. Or you can actually see people using coaxial cable. That's your regular cable, right? Or your cable company. Or you can actually use a fiber optic cable. What does these, this RJ45 has different categories. So because the technology advances, their categories are advances. Just to give you, it starts from category 3, Cat 5, so you can even have people refer to them Cat 5, Cat 6. So Cat 3 supports up to 10 megabits per second. What does that mean? So if the data is going from this computer to this computer, that's the speed that it's going to go. It's not the speed of your server, it's the speed of your transmission of your data. Imagine that that you are using a car. The analogy could be a car. The speed of that car and is one thing, and how fast you drive is another thing. So this Cat 3 cable can handle traffic up to 10 megabit per second. This is how actually we communicate. When you go, for example, on a highway, you can say I was going with 70 miles per hour. That's going to tell us how fast the car was going. Here, this is going to tell us how fast the data is traveling, 10 megabit per second. Cat 5, about 10 years ago, they came into the market. It was amazing. They actually supported up to 100 megabit per second. Cat 5e, almost 1 gigabit per second, right? 1000 megabit is 1000 gigabit. Cat 6, again, similarly, but the maximum bandwidth were larger. Cat 6a, 10,000 megabit per second. Cat 7 today is 10,000 bit per second, but again, the maximum bandwidth is even higher. As you can see, as the technology improves, the speed that you carry over the networks also is improved as well. So, and of course, fiber optic is another cable. This is indeed the fastest cable in the world today. There is nothing that is even close to fiber optic. Fiber optic is not actually a cable. In the twisted pair, look at these. These are actual real wires. They are twisted. They could be either shielded or not shielded, but they are actually cables, copper inside. But in fiber optic, there is no actually wires. There is only glass. So the data goes through like a mirror. So it goes through much faster because it's not going through a wire. For that reason, imagine that you're creating different mirrors inside, and the data goes. The speed of light is much faster than the speed of the data in a wire. So fiber optic is definitely. So what does that all means to you as a hospitality student here? So for example, we didn't talk about digital subscriber line, DSL, yet, but we are going to talk about it. So the DSL, if you're using DSL to connect your computers in, let's say you create a wide area network, and then you are going to do, you're going to actually achieve 6 megabit per second download speed. So if you were to go into a different cables or fiber optic, that you will be able to, as you see, the internet speeds increases, and the time it takes, for example, to download 8 of your favorite songs is 54 seconds to a 0.3 seconds. It's not even a second, like is the third of a second. It's unbelievable, right? And these are only increasing, getting better and better. So thanks to fiber optic. What is fiber optic cables advantages? Superior system performance, increased bandwidth and capacity, lower signal loss. With the twisted pair, RJ45, Cat 5, Cat 6, Cat 7, The problem is that if the actual wire gets longer, you actually lose the signal. So you need to put sometimes repeaters every 100 meter when this cable is actually set. But in fiber optic, do not worry, because it's light, goes inside, there is no signal loss. Also, the wires like RJ45 twisted pair cables are not immune to electrical noise. If there are other devices around you, that they are actually going to be impacted by them, but not in fiber optic. And also, fiber optic is the signal that it carries is much more secure, is more difficult to tap into. But one disadvantage is cost. It's much more expensive than anything else in the market. Okay, so we talked about topologies very briefly before. So we're talking about LAN, right? Local area network. So we talked about what do we need? We need a server, we need the cables, and also we need workstations, right? We need a network interface card, we need a switch. We all talked about it. And network topologies actually tell us how we can place these computers, workstations, or the servers, or even nodes, as we call them, other things in the network, such as printer, for example, scanner, or kitchen printer, right? Kitchen display system, in a network physically and logically. So that's the definition of network topology. There are 4 different types: bus topology, ring topology, star, and mesh. The most common one is the star right now. Here's one example, bus topology. It's the first topology, one of the first topologies when networks were primitive in the beginning. So you simply take one cable, you put all computers, workstations in there, as you can see in this picture here. The disadvantage of it, it's cheap, it's easy, but when one of the workstations in the bus topology fails, the whole network goes down. Star topology is amazing. You connect all these computers with the help of a switch or a hub, remember, although hubs are not used anymore because they are not smart. Switches are smarter. So if this computer wants to send a signal to this computer, switch is the connector to that. Ring topology is used in sensitive areas such as accounting and finance department. So in this one, for example, in the star topology, you can actually add more nodes in here, but in the ring topology, it's much more difficult. Okay, now let's talk about wide area network. A wide area network links computers in a LAN set up over a great distance using a digital subscriber lines or cable modem networks, fiber, satellites, microwaves stations, or cellular broadband technology, and or a combination of these. So for a WAN to be a WAN, at least 2 local area networks needs to be connected together. So here's one LAN here. Imagine that this is hotel in New York and this is another hotel in Miami. So you can connect these 2 LANs together and you create a wide area network. Wide area networks are amazing because they enable us to share data in an unprecedented way that we never had in the history in the past. So this is a sample WAN as we show in the example here, and here these are all workstations that are connected, and you can create a WAN when you connect different. So you have seen that, and you can also create a network by using a Wi-Fi networks. Wi-Fi stands for wireless fidelity, and you know, everybody is familiar now with Wi-Fi. So everywhere we go, people are saying that they are asking for Wi-Fi. You go to a coffee shop, you go to a shopping center, you go to the university, you go anywhere, even to a level that now Maslow's hierarchy of needs are showing Wi-Fi before even physical needs, and along with battery. It's really funny when you think about this. But in reality, what really that tells us that Wi-Fi enables us to communicate freely without the wires. That's really an amazing technology. It's relatively new. In the last 20-30 years it is developed. The IEEE is the organization, International Electrical and Electronical Engineers. That's the name of the organization, and they created a standard for Wi-Fi. This is the reason when you go to USA versus Germany, you use the same Wi-Fi. But imagine, for example, the governments or the scientists could not achieve this standard when it comes to plugs. When you go to UK, you are using a different plug and a different voltage than you go to, let's say, Germany or USA. Right? They are all using different plugs. But in Wi-Fi, they were smarter. When they created a standard. This is international standard. So when you go to a coffee shop in Indonesia, you say, do you have Wi-Fi? It's the same thing that means in California or in America or in Peru or in Turkey. It's exactly the same thing. So this standard is called 802.11. That's the first one. And there are different variations of it now. A, B, G, N, and finally AC. What do they mean to you? Is that, look at this, 802.11g is actually 54 megabit per second. As a matter of fact, B actually supported only 11 megabit per second. So again, that's the transmission of data from one point to another. So this tells me this different letters after the 802.11. You may not even notice this, but if you were to buy a laptop or whatever, it always has this among one of the features, 802.11n, for example. N is again relatively new, maybe in the last 10 years it started to be used. It is actually allows you to go all the way to 300 to 450 megabit per second speed. And AC is brand new, actually. It just came in the last couple of years. It actually is the first time Wi-Fi can go into the speeds of gigabit. 1300 megabit per second, 1300 megabit per second equals to 1.3 gigabit per second. So basically Wi-Fi catch up with the wire. As you can know from the previous examples, wires allow you to communicate, carry data faster, but Wi-Fi is catching up. So that's really good news for us. So here's an example of a LAN and a WAN. So imagine this is like the example that I gave you earlier. This is a hotel in New York City. It could be Marriott, Hilton, Hyatt, whatever that might be, and that's in Miami. So I want to connect them. How can you connect them? You can connect them by a variety of different things, even dial-up. You may not remember dial-up, but in the old days when internet was first started to be used by general public in 1990s, we used to actually call a dial-up modem to be connected to the internet. There was this famous sound, you know, make that sound. It was actually made us happy because that means that you connected to the modem. So you can even connect to LANs by using a dial-up, which is, by the way, sometimes a backup way of connecting for some wide area networks. You can also use the speed of dial-up is 56 kilobit per second, so it's very, very slow. It will really make you pull your hair, but it works. And sometimes some government employees are only allowed to connect to their service by using dial-up because of security features. ISDN is 128 kilobit per second. DSL, digital subscriber line, supports up to 1.5 megabit per second, or you can use cable 3.5 megabit per second or bigger. These are called all shared connections. So you can actually use a internet service provider and use these services from them. But shared connection is equal to, let's say you are going from your home to the airport. Let's say I'm going to give you my example from Sarasota to Tampa airport. We are using I-75 or I-275 to go to airport from here. In a shared connection, you never know how long it's going to take you to go to Tampa because it depends on the traffic. That highway is shared by other people. However, if you had a dedicated line, then that means that in the analogy that let's say that I-75 is only open for you, nobody else can go there, then you can predict very precisely how long it's going to take you. You can actually go even much faster than many cars present there. Same example, if I were to connect these two LANs together, these two different hotels, I can also use dedicated connection lines like T1, 1.5 megabit per second, or frame relay, same thing. These are different technologies offered by internet service providers that allows you to connect your LANs together. T3, 43 megabit per second. OC is fiber optic cable, optical cable networks, 155 megabit per second. By the way, these are right now, as we speak, any day these speeds are increasing, but I'm just reporting to you right now the speeds that are accepted as the standard average speeds. Or you can use ATM, which very big large companies use, like Google for example, or Marriott, to actually use this. They even put this under the ocean to allow their service to work together. Or I can actually use these Wi-Fi standards. Remember we talked about them earlier. 802.11b, that's the again, not too long ago, maybe 10 years ago, we used to use 802.11b, which means that, you know, when you are, if there is a Wi-Fi connection between the switch and this computer, that data transmission speed is 11 megabit per second. And now today you got gigabit megabit per second, 1.3 gigabit actually, with the wireless network. So this is wireless local area network, dedicated or shared. It depends on who else is using your wireless network versus if it is just you. So here's a demonstration. You know, this is could be a hotel here. You have a wired LAN here, and you can have wireless access points. Imagine that this is your lobby and this is your meeting areas. You can put access points here. You still have wires. Wireless doesn't mean no wires. There's still wires that goes into the access point, which then serves an area. In a hotel environment, actually, this, if your lobby, let's say, is this one, this is not very good because you have some dead spots here. That's why when you go to a, let's say when you have a computer, let's say your phone, and you are moving from one area to another, sometimes the Wi-Fi disappears. That's what happens. These access points have ranges. In a good organization, you actually take a measure of those Wi-Fi signals. You can measure in every corner of your hotel or restaurant to ensure that there is good coverage everywhere. So let me just tell a little bit about Wi-Fi. This video will show that to you. It's very interesting. This video was done by AT&T. That just shows you different internet speeds. Let's watch this.
Internet speed, also known as bandwidth, is the maximum amount of data you can send or receive over an internet connection, usually measured in seconds. Your internet plan probably has a name like Internet 100. The name refers to how much bandwidth you have. The 100 refers to 100 megabits per second. The more bandwidth you have, the faster you can send and receive data. Think of internet speed as the checkout line at the grocery store. If there's only one lane open and you're the only person in line, you get through pretty quickly. But if there are 4 people ahead of you, it will take you longer to check out. What if 4 more lanes were opened? You could all check out a lot faster. When you have many devices on your network, or when you are running many applications, you may not have enough speed and you might slow down as you wait in line. When you add more bandwidth to your internet speed, you can do things online faster. Remember, your internet speed is shared among all the devices connected to your home network. Think of sharing your internet speed as sharing a pizza that's cut into 8 slices. If you're alone, you can eat all 8 slices. But let's assume you're sharing it with a friend. Each of you can have 4 slices. If 2 more friends join you, there are 2 slices for each of you. The point is, as you connect more devices to your home network at the same time, there's less internet speed to go around and your internet connection may feel slower. This often helps explain what's going on when web pages are slow to load or when you're streaming your favorite TV show and your video stream is buffered and choppy. Your devices might also slow things down. All the devices on your network take turns communicating with your Wi-Fi gateway one at a time. Older devices connect to your network at slower speeds because they use older, slower Wi-Fi technology. Your newer devices, which use the latest Wi-Fi technology and connect to faster speeds, might be slowed down temporarily when they wait behind older ones to communicate with your Wi-Fi gateway. But even among the latest devices, you may see speed differences. For example, your laptop's connection may be faster than your smartphone's. This has to do with the number of antennas in a device. Wi-Fi devices send and receive Wi-Fi signals over antennas, much like a radio does. Devices with more antennas can send more data at the same time, making their connections faster. Smartphones might have 1 or 2 antennas built into them. Newer laptops may have 3 or more. That also means that even some of the latest Wi-Fi devices may not have enough antennas or other hardware necessary to take full advantage of the fastest internet speeds available today. Finally, it's important to remember that a Wi-Fi connection will almost always be slower than a wired one. If you connect your new laptop to the internet using Wi-Fi, but later connect it to your gateway using an Ethernet cable, you'll find that the wired connection will be faster. Visit att.com/optimize your connection to find out how to get the most from your internet speed. Thanks for choosing AT&T.
The wireless standards does not stop with just Wi-Fi 802.11. There is also another technology which is relatively new that is invented after Wi-Fi, which is called ZigBee. ZigBee is just a wireless standard language that connects people, just like Bluetooth is, right? This one is 802.15. The difference between Wi-Fi and ZigBee, ZigBee is used usually from device to device. If you go to a hotel, that you may actually find ZigBee between the energy management system and the TV and the controller that controls your lights. ZigBee is a little bit interesting and better than Wi-Fi in some aspects. It consumes less energy. And it could be cheaper. Here's one example. Even in your home, you could use ZigBee, or in retail, in lighting, it's used to control lighting and all these different industries. And there is also a newer technology called Li-Fi. Li-Fi is light fidelity, similar to Wi-Fi, but in this one, it's a high-speed two-way wireless communication method using LED lights equipped with specialized internet chips for transmitting and receiving Li-Fi data in the form of light pulses or signals invisible to human eye, just like Wi-Fi, right? There's a lot of signals around us, but we don't see them. So the market for Li-Fi, it's a newer technology, may grow rapidly because of several advantages over Wi-Fi. It's higher data transmission, better data security, and broader bandwidth. Best Western showcased Li-Fi at its 2015 annual conference as a future way of bolstering short-range mobile connectivity and providing unprecedented internet connection speed in rooms. So there are, of course, Wi-Fi, Bluetooth, ZigBee, Li-Fi. These are all different wireless standards, communication ways for devices to talk to each other. Here's one video about Li-Fi.
Imagine a world where light becomes data. Li-Fi is simple but powerful. We all know how a light bulb works. When an electrical current is applied to an LED light bulb, a constant stream of light is emitted from the bulb, which we see as illumination. Since LED bulbs are electronic devices, the current and therefore the light can be modulated at extremely high speeds. This can be detected by a photodetector and converted back to electrical current, therefore carrying data. This is the nervous system of an internet revolution. Li-Fi doesn't replace your internet service provider. You'll still need them to get the internet to your home or office via wires. However, once you have that high-speed connection, you can deploy your fast, secure Li-Fi network using power over Ethernet or power line communications. Li-Fi offers greater density than many other radio frequency solutions. For example, if you have an average Wi-Fi router in your office that provides up to 100 megabits per second and 15 people are connected to that router, It means that you might only be able to access 4 megabits per second. However, with a Wi-Fi network of lights that offer 42 megabits per light, even if you had only 8 lights in your room, those same 15 people could share more than 300 megabits per second. That's dense and fast wireless communication. Real Wi-Fi is also bidirectional, full duplex, and high speed. Data is transmitted and received at the same time, resulting in a really fast, reliable user experience, especially when doing things like Skype calls, video streaming, and virtual reality. Real Wi-Fi is fully networked. That means all the lights in your Wi-Fi network can speak to each other and hand over as you move around the space. Each light even has its own IP address, which means that you can offer location tracking and geofencing within your network. Wi-Fi, a world with unprecedented data and bandwidth. Be part of the light revolution.
Okay, now we talked about different parts of the networks, and let's talk about planning a network in a hotel, for example. So you need to look at the hotel characteristics. I worked in a consulting work one time in Bangkok, Thailand, that this hotel was about 50 stories long. It was made of course, concrete, and the lobby was in, the concierge was, and the entrance to the hotel was in the first floor, and the lobby was on the 30th floor, and then you had all these rooms on the top, 30th to 50th floor, and with on the top penthouse, bar, restaurant, etc. So for example, when you design a network for this hotel versus, let's say, a Fairfield Inn by Marriott, right, which is let's say 3 stories long, it's very simple, made of let's say wood or other construction type, it's going to be different. So the hotel characteristics determines how you are going to design. Wireless local area network, for example, in this hotel in Bangkok, as I told you, putting a cable from the first floor to the 50th floor, fiber optic, could be super expensive. So you are going to maybe use an alternative like Cat 5, Cat 6, or Cat 7, right? But in the case of a Fairfield Inn, a small hotel, you can easily connect the devices by using wireless Wi-Fi. And wired network infrastructure, what's there before is important. Again, if an old hotel is made with concrete and marble on the floors, you can't really, easily put wired connection there, so you're going to have to use alternatives. Or if you have your point of sale systems in Grand Canyon, where you cannot use wires, that you're going to have to choose for wireless devices there. Access point location, remember when we were showing the wireless coverage, access point locations, so that you can have a full and good coverage entire your organization, hotel, restaurant, whatever that might be. Network security is another factor to decide how am I going to secure my network. Is it going to be open to public? If that's the case, then maybe you will separate your business network than your guest access, public access network. Bandwidth capacity, if you are in a hotel and you advertise free Wi-Fi, and if you are using only, let's say, T1, which is only 1.5 megabit per second supports, then you're going to have a lot of complaints. People are going to say, are you kidding me? Wi-Fi become one of the most important factors when someone decides selecting a hotel. For that reason that, for example, you may actually want to install T3 in your hotel so that you can support the bandwidth requirement as your hotel becomes bigger. And wireless technologies and standards, like we talked earlier, ZigBee. Maybe you will use ZigBee technology in your room that will communicate between devices in your room. Let's say your energy management system to your door, to your TV, and to the other things in your hotel. So networks needs to be managed. You can't just create a network and say, hey, good luck network, manage yourself. You can't do that. In any kind of organization, if you have a LAN or WAN, wider network, you need to manage it. In a LAN environment, what you need to do, the functions of network management is fault management. If this computer here that are connected to my network here doesn't work, I need to know that. So network management systems, which is also a software, will tell you. Or if configuration management is another function, which means that if I have a new person joining my hotel, let's say in the front desk, I need to open, and he or she is going to use this PC here, then I need to open a user name and password for that person, which will needs to be disabled after that person is left the company. So you all do this one with the configuration management function of the network management systems. Performance management is another one. You manage the performance of these computers if they are all functioning good to the optimal speed. If not, you're gonna fix the problem. Security is another one. If you have an intruder here that comes into or would like to come into your network, then the system, network management system, will actually alert you so that you can secure. And finally, the accounting management refers to the way that, you know, the networks cost money. So that's a cost center in a hotel, for example, and you need to distribute these costs. One of the best ways of distributing the cost to all these revenue generating departments is actually usage. So network management system keeps track of who's using what, all of these network, and then you can, based on that percentage, you can distribute these costs to different departments. So this concludes this particular topic here. I hope you enjoy it. Please subscribe to my hospitality technology channel and watch other videos, and please feel free to share these videos, which I happily and publicly share on YouTube. Thank you.